Okay, so let's start today's session और आज हम करने वाले हैं आर्हेनियस ब्रोंस्टेड लोरी एंड लुइस एसिड बेस कंसेप्ट। एसिड बेस जो कंसेप्ट है उसका पूरा डिटेलिंग करेंगे हम आज। ठीक है, जैसे आर्हेनियस कंसेप्ट है, पहले हम डिस्कस कर रहे हैं उसकी लिमिटेशन क्या है। ठीक है, ये सब आज करने वाले हैं अभी हम। और बिफोर गोइंग इनटू डिटेल, पहले वीडियो को लाइक कर देना। ठीक है, ओके, सो लेट्स स्टार्ट आर्हेनियस कंसेप्ट ऑफ एसिड्स एंड बेसिस। तो अकॉर्डिंग टू आर्हेनियस, व्हाट इज एसिड? सो acid is the one which should have hydrogen. According to Arrhenius, the acid is the one which gives free hydrogen ions when dissolved in water. When we dissolve the substance in water, if it gives H plus ion, free H plus ions from the substance, so that is called an acid according to Arrhenius. For example, HCl. HCl will give H plus and Cl negative ion in solutions. That means it will give H plus. Nitric acid, HNO3, it will also give H plus. Sulfuric acid, again give H plus ion. So these are acids, and these are strong acids because they are completely ionized. They are completely ionized into H plus and anion, and that's why we put only one arrow, that is direction is unidirectional ionization is there. But if we have a weak acid, okay, like acetic acid, phosphoric acid, okay, then see there is a double headed arrow, means it is at equilibrium, because in the solution unionized acid and ionized acid, they are in equilibrium, or we can say unionized molecule and ionized molecule, they are in equilibrium. Okay, I mean to say acid is the one which give H plus ions in the aqueous solution. If the substance is dissolved in water and it give H plus ion, then that is called an acid as per Arrhenius concept. Okay, now they are of two types, strong acids. So in case of strong acids, they are completely ionized in water, and that's why there is only single direction, means arrow is in the forward side only. In water it cannot be reversed. Okay, means H plus ion will not combine with Cl negative ion. Once H plus ion Cl negative ion are separated in the water, they remains as such in the solution. Okay, but when we talk about weak acids like acetic acid, phosphoric acid, then there is an equilibrium because they are feebly ionized, means they are ionized to a small extent. They ionize to a small extent. Okay, so it will give H plus ion, acetate ion, H plus ion, phosphate ions. Okay, and H plus ion can combine with acetate ion to give back acetic acid. So in equilibrium mixture, in the mixture, this acetic acid, H plus and acetate ion, all of them are present. But in first case, in this case, only H plus and Cl negative ions are present. In H plus and NO3 negative ions are present. HNO3 in combined state is not present. That's it. That's what I said. Okay. Got it? Now, according to Arrhenius concept, what is base? So base is the one which has hydroxyl group and which give free hydroxyl ions when dissolved in water, like sodium hydroxide, potassium hydroxide. They are strong bases, again unidirectional, but weak bases like ammonium hydroxide, aluminium hydroxide, they are ionized to a small extent. They are ionized to a small extent. So they will give small amount of NH4 plus and OH negative ion along with NH4OH. Means in the solution itself, NH4OH is present, NH4 plus is present, OH negative ion is also present. All of them are present and they are in equilibrium. Unionized form of base is in equilibrium with the ionized form of the base. This is the ionized form of the base and this one is unionized form of the base. Same, aluminium hydroxide is in equilibrium with Al3 plus and 3OH negative ion. Means unionized form of aluminium hydroxide is in equilibrium with ionized form of aluminium hydroxide. Right? And according to this concept, when this H plus ion, which is released from the acid, that will combine with OH negative ion of the base, then we get molecule of water and which is neutral, and this is called neutralization reaction. This is one type of neutralization reaction. Now, what are the limitations of this law? So if we talk about limitation of this law, so first limitation should be yes, but is it okay? Clear हो गया यहाँ तक? Any doubt up to this? Simple, acid is the one which give H plus ion and base is the one which give OH negative ions. ठीक है? Yes, but okay, so let's continue. So first limitation is nature of H plus ion. So what we said, that acid is the one which give H plus ion, but H plus ion cannot exist as such. It is not a particle which can exist independently. Okay, because H plus ion always present in combination with water in the form of hydronium ion, and So we write it as H plus aqueous or H3O plus aqueous. Second limitation, you know what we write? Acid is the one, acid is the substance, uh, which substance? Hydrogen containing substance. So the one which has no hydrogen, according to Arrhenius, is not an acid, like CO2. You know, CO2 is an acid. SO2 is an acid. But according to Arrhenius, they are not acid. So this problem can be solved when it is dissolved in water. It will give carbonic acid. SO2 when combined with water, it gives sulfurous acid. Okay, and then they will give, which in turn give H plus ion. Okay, and in this case, third limitation is it is restricted to water as a solvent only, because we write when it give H plus ion in water, when dissolved in water, it give OH negative ion. Base is the one which give OH negative ion when dissolved in water. So water is the limitation. That solvent should be water in this case. So if we use some other solvent, then Arrhenius concept is not able to tell us that is it acid or base. Got it? Means only when water is the solvent, then only it tell us that is it an acid or base. Yes, madam. Got it? Now comparison of their acid, comparison of strength of acids and bases. So to compare, according to Arrhenius concept, according to Ostwald dilution law, what is degree of dissociation? वाह साद, क्या हाल है तेरे? What is degree of dissociation? It is equal to square root of Ka over C for acid, and it is equal to square root of Kb over C for base. What is Ka and Kb? Ka and Kb are dissociation constants of acids and bases. And C is molar concentration. Okay, so to compare their